All right, here's my first recording to my Algebra 1 class. Are you guys excited? I am. This is going to be great. So much fun. All right, so here is my basic slide setup that should go right off your guided notes. So 6.1, solving systems by graphing is what we're going to do. Make sure you put your name at the top and the hour you're in, just so I can keep them organized if I ask you to turn them in. The objective here is very important: to solve systems of linear equations, which just means lines. Solve lines by graphing. Okay. Materials you need: I would probably have multiple colors. They can be pens or pencils or crayons or markers. You don't even need like a whole box of 64, but if you have like 3 or 4 different colors, that'll help out a lot. Alright, let's get started. First off, let's review. Okay, what is a linear equation? Alright, there are 3 types of linear equations. One, there is slope, intercept. Alright, the other one is point slope, and the last one is standard. And if you look just below on your sheet, you have all 3 of those down there. Okay, and I'm basically asking you, what is each one of these? Okay, how do we find the parts of each one of these? So here's slope, intercept. We know what y and x is. They're any point on the line. M is what? M, you should know this, you better know this, is the slope. B is the y-intercept. M, again in point slope now, is the slope. Nothing changes there. X1, Y1, right there, is our point. A point on the line. Point on the line. I'm running out of space. Hopefully you're not. Standard form. Standard form we graph using intercepts. Okay, so the x-intercept, if we want to find the x-intercept, we let y be 0. That cancels all this out, and it's just c over a. And if we want to find the y-intercept, then x is 0, and it's just c over b. And then we can graph it. Alright, so let's do some examples here. I have this example right here. The y-intercept is -4. So I go to -4, and the slope is 2 over 3. It's positive, so it's going to be moving up. So rise over run, up 2 over 3. And it's about right there. Okay? Now, I'm just going to go ahead and draw in my line. Let's see. Let's use this one. There's one end, and here's the other end. That's what my line should look like. Alright, next one, point slope. So again here, my point, the y is 2, so the point is -3, 2, because that's positive. Okay, so that's opposite of what it should be. That's 2, because it's -2, so y1 is just 2. Alright, so here's my point, and the slope, which is m, is 2. So we go to -3 on the x-axis, which is right here, up 2, which is right here. Alright, and now the slope again is positive, so it should be moving up from left to right. And we go up 2, 2 over 1. And it's about right there. Once again, let's make our line. Boom. Boom. Okay? Alright, we're moving right along. Let's do the last one, standard. X-intercept is c over a, so a is 2, c is 6. So the x-intercept is 6 over 2. Okay, which is, sorry, this thing is locking up on me now. There we go, is 3. And so x-axis, I go to where 3 is at. and make a dot. The y-intercept is c over b, so 6 over 3, which equals 2. There we go. And again, back to my beautiful line. Boom. And boom. Alright. Alright, moving forward. So we should all know what a linear equation looks like in equation form. Right? We have point slope, slope, standard form. Those are all equation forms of lines. Alright? Or we know they all make lines on a graph. So there's two ways that we can see them. One is on a graph, the other is equation form. A system of linear equations is two or more linear equations. Okay? So a system of linear equations is two or more linear equations, or lines. Lines. Okay? Should be a period there. For example, problem 1. I have two linear equations here. What form are they in? Write that right out here. They're both in the same form. What are they in? Should have put slope intercept. So let's identify the parts. Okay, let's go right through this. The first equation, the slope is what, and the y-intercept is what. Second equation, the slope is what, and the y-intercept is what. On this first one, the slope is 1, the y-intercept is 2. On the second one, the slope is 3, the y-intercept is negative 2. Alright, so I have one line, and now we're going to use some of our multiple colors. We have one line that is at 2, okay, and has a slope of up 1 over 1. It's a positive slope, so it's still moving in a positive direction. And we're going to use this. It's not giving me an option for a red line. Let's use this dash line. Even though that has little to do, I want to make sure you can see the difference. You should probably still be using red or your other color. Alright, so here's red. This next one will be green. So the y-intercept is negative 2, and the slope is up 3, 1, 2, 3 over 1. And now for my lines, I'll make this one solid. There it goes, and there it goes. Okay? Alright, now this one should be able to tell you what the solution is by just looking at it. The solution is right where they, whoops, still using my lines, gosh darn it. The solution is right where they intersect. It's right there. Okay? Solution is the point where they intersect. Once you find that point, count it out. You can write it down and check it. Here's example 2 and 3. Why don't you try those now, and I'll come back and do them here in just a second. Go ahead, hit pause on the video, and try them. Alright, so hopefully this is what you got your answer. I'm going to walk you through this real quick. Again, the red is kind of highlighted here. But I just took this equation, I solved for y, so it was a slope intercept, real easy to identify what is what. And then that line is right here. I took this other one, again, solved, put into slope intercept, so everything is easy to identify. And that line is right here. The solution to this equation is where they intersect. And I just counted out on the graph, negative 1, 3. Let's check it. If I plug negative 1 in for x, I get negative 1 times negative 2, which is positive 2. 2 plus 1 is 3. Let's try it on the other one. Take negative 1, plug it in for x. Negative 1 times 2 is negative 2. Negative 2 plus 5 is 3. So that means that this point is on both of these lines, and it does solve both of these lines, which means it is the solution. If you plug in any other number besides negative 1 for x, you will get two different y's. That's how you know they do not. It is not a solution. Okay? Same thing over here. I had some combining to do. I took a positive x, moved over here, ended up with 2x. Okay, no big deal, still just solving for y. End up with my two lines. Solution is up here. 2, 9 is a solution. There you go. Alright, Things to think about. What does a solution with no what does a no solution graph look like? We've seen them, and I've told you that the solution means they are intersecting. Well, what does it mean if they have no solution? Does it mean they don't intersect? What kind of lines don't intersect? What does an infinitely many solution look like? Okay, not just one solution, but everything's a solution. What does that look like? All right, there's your homework if you want to go ahead and get started on it. Come in, get ready to work tomorrow. All right, see